I'm Miss Lee. Today we will investigate the question, what causes an object to stay at rest even when a force is exerted on it? Are you ready? Grab your pencil and your science journal and let's get started.
Look at these notebooks. They look like plain old school notebooks, right? But watch this. Here, two notebooks are pushed together by interweaving the pages, putting one page of one notebook on top of one page from the other notebook. What do you think will happen if we try to pull the notebooks apart? Make your prediction. Ready to see what happens? Look at those notebooks. The notebooks stay together no matter how hard someone pulls on them. Why do you think the notebooks don't move apart even when someone pulls on them? We know that if an object doesn't move, the forces acting on the object must be balanced. Maybe another force is acting on the notebooks that is equal in strength to the force that the person is exerting. Maybe the force is friction, or maybe it's some other force. I wonder, what causes an object to stay at rest even when a force is exerted on it? What could we use to help investigate this question? I know, we can use the Atwood machine. The Atwood machine has been really useful for investigating motion and forces so far. I wonder, how could we use an Atwood machine to determine what causes an object to stay at rest even when a force is exerted on it? We'll need to start with the block at rest, of course, but then we'll need to exert a force. What ideas do you have for how we should exert that force? I know, let's attach one cup to the block and then see how many pennies we can add before the block starts to move. Before we attach the cup to the block, we'll make our first observation. What do you notice about the motion of the block? I notice there is no motion. The block isn't moving at all. So with no cup, the block does not move. What do we know about the forces acting on the block while the block is at rest? We know that gravity pulls down on the block and the table pushes up on the block. How do you know if these forces are balanced or unbalanced? Since the block doesn't move, the forces are balanced. Now let's attach the cup to one side and add 1 penny to it. What happens? Nothing. With 1 penny in the cup, the block does not move. Let's try adding a second penny. Still nothing. With 2 pennies in the cup, the block does not move. I will add more pennies to the cup. Wow, I get the same results each time, even if I add 3 pennies, 4 pennies, or 5 pennies. The block does not move. I wonder why the block does not move. If the block does not move, are the forces balanced or unbalanced? Let's use what we know to answer that question. Even though there are 5 pennies in the cup, the block stays at rest. So the forces must be balanced. What other forces are involved now? Well, we know that the string exerts a force on the block. An unknown force must be acting in the opposite direction of the force exerted by the string to keep the forces balanced. What can we do next? I think we can make this block move. Let's see if the block will move with our 6th penny. Whoa, did you see that? We made the block move. So with 6 pennies in the cup, the block moves to the right. Are the forces balanced or unbalanced now? When there are 6 pennies in the cup, the block begins to move to the right. The forces acting on the block are unbalanced. I wonder what happened to the unknown force acting in the opposite direction of the force exerted by the string. I was surprised by some of our observations. Were you? Your first task for today is to think about the relationship between forces and motion. Think about the relationship between forces and motion. Do your observations from this lesson support what you know about that relationship? Explain your answer. I wonder, what force acts on the block in the opposite direction of the force exerted by the string? We learned about this force last time. It's friction. Friction is acting on the block in the opposite direction of the string. This holds the block in place. Your second task for today will be to answer the question, why does the block stay at rest even when we place 1 or 2 pennies in the cup?
Welcome to today's lesson. I'm Miss Lee. Today we will continue to investigate the question, what causes an object to stay at rest even when a force is exerted on it? Are you ready? Grab your pencil and your science journal and let's get started.
The other day I tried to move furniture in my home. Even though I pushed on the couch really hard, it didn't move. Why do you think I couldn't move the couch? Hey, what about friction? Maybe you're thinking that the opposing force of friction was stronger than the force of my push, and that's why the couch didn't move. Hey, that reminds me of our last lesson. Do you remember what we learned? We learned about friction by using the Atwood machine. We drew 3 force models. Today we can add our new knowledge to revise them. But guess what? One of these models does not need to be revised to include friction. Which model do you think that is? Did you find it? Okay, let's get started. Okay, there's the first model. What's happening in this model? In this model, no string and no cup are attached to the block. So what forces are acting on this block? I see gravity pulling down on the block, and I also see the upward push from the table. Do we need to revise this model to add friction? No. This block is at rest. Only 2 forces are at work in this model, and they're balanced. So we do not need to add friction. Great. Now let's revisit the second model. What's happening in this model? Well, I noticed that in this model, the string and the cup are attached to the block. Do you remember what happened when we started adding pennies to the cup? We added up to 5 pennies, and the block still didn't move. We decided that an unknown force was acting in the opposite direction of the force exerted by the string that kept the block from moving. So, can you find friction in this model? Hey, do you think that unknown force is friction? It is. But the friction is balanced with the force exerted by the string. In fact, because the block didn't move at all, we know that all of the forces acting on the block are balanced. Let's look at the third force model. What's happening in this model? Well, in this model, we added 6 pennies to the cup. Do you remember what happened? The block moved toward the cup. Can you find any friction in this model? Well, in our last model, we decided that the unknown force was actually friction. Do you think this force is friction in this model as well? It is. In this model, the downward force of gravity is still equal in strength to the upward push exerted by the table. But the string exerts a force that is stronger than the opposing force of friction. Because the forces acting on the block are unbalanced, the block starts moving. Great job updating these force models. Remember these notebooks? When a person tried to pull them apart, the notebooks wouldn't separate, no matter how hard the person pulled. Now that we can describe the forces acting on the block in the Atwood machine, do you think we can also explain why pulling the notebooks apart was so difficult? What do you think caused the notebooks to stay at rest when a person pulled on them? Do you think the cause was friction? Yes, friction is exerted by objects that are in contact. Because so many of the pages of these notebooks are in contact, they exert a lot of friction on each other. All that friction makes the notebooks extremely difficult to pull apart. Remember the furniture story I told you about? Guess what? When my family member and I pushed together, we were able to move the couch easily. I couldn't exert a force that was stronger than the friction on my own, but together we could successfully overcome friction and move the couch. Friction affects the motion of objects. What are some everyday examples of how friction affects the motion of objects? For your first task today, you will answer this question in your science journal. Your second task will be to summarize what you have learned in this lesson about forces. I can't wait to continue exploring forces with you. Let's review your task for today. First, answer the question about everyday examples of friction. Second, summarize what you learned about forces in this lesson.